Well, hello friends, and welcome to the SerenityOS update for February 2021. Now, before we begin, let me tell you about sponsorship. So, the Serenity operating system and all of my content about it is always going to be free and open source. But if you would like to support my work and maybe one day make it possible for me to do this full-time, then there are 3 donation options. So I'm on GitHub Sponsors and Patreon for those who would like to make a recurring monthly contribution, and I'm also on PayPal if you prefer to make a one-time contribution. And I have links to those services in the video description below, so check that out. And of course, as always, a huge thank you to those of you who are already supporting me in some way. And also welcome to all the new sponsors who have joined in the last month. It's been quite a few new people and it's very awesome. So thank you and welcome. Okay, so let's look at February. So for me personally, this month continued on the security track, which I've been on since Christmas. But a bunch of people have been working on the system, of course, as always. So there's various things to look at. Some of the things I'm the most excited about security-wise is we now run the kernel with undefined behavior sanitizer always compiled in. So the ubsan thing that both GCC and Clang support. So if there is ever undefined behavior triggered, we can now get a log message about it. And this has been really successful in just exposing lots of tiny kernel bugs. And one thing that really helped kubsan was Ben wrote a Syscall Fuzzer. So we now have a Syscall Fuzzer called Fuzz Syscalls. It's in user tests kernel. And, well, you can't see my debug output here, but basically it just runs a bunch of syscalls with random arguments and tries to provoke the kernel into hitting a bug. And thanks to kubsan, we were able to hit lots of bugs. So thank you very much, Ben, for working on that. Some other cool stuff is in the kernel, we now have 2 new types of memory. We have read-only after init and unmap after init. So basically, we divide the kernel into 2 stages. There's the init stage, and then there's the post-init stage. And basically, the transition happens when we start up the system server, so when we spawn user space for the first time. And we now have a way to specify variables and functions that are not necessary once we have crossed into user space. And then we can actually unmap those, so they are no longer callable. And we can also reuse the memory that was used for those things. So that's unmap after init. And then we also have read-only after init, which is sort of halfway there, that we have some piece of memory that's might get written to during initialization, but once we've booted user space, we know that we're never going to write to it again, so we make it read-only. So that stuff is pretty cool. And we also now compile everything with fstack clash protection, which is a compiler flag that protects against stack clash attacks. And I've added randomization to both user and kernel stacks. So we now randomize some of the lower bits to add like a little bit of offset, which makes both kernel and user stacks unpredictable, or at least less predictable. So a lot of interesting kernel security things happening. And another thing I did was, I also added a new, let me see if I can type here, a new pledge promise. So we now have a promise called, oops, can I scroll, map fixed. So this is now required if you want to mmap with map fixed. So the idea here is to just, map fixed is not used by a lot of programs, and it is very useful when you're building exploits and you're trying to massage your address space to look a certain way that's conducive to exploitation. So I figured, why don't we take that away from the vast majority of programs that don't even need it in the first place, right? So that's a new pledge promise, and I think it's very reasonable one, but we'll see how that works out. And another thing is, let me show you with PMAP actually. So we'll look at the terminal that we're in. So we now see that we have a region right here where we have mapped libsystem, and it has a C flag. It's the only thing with a C flag. And the C flag means that this region is allowed to call the kernel. It's allowed to make system calls. So what we've done here is all system calls now have to go through this memory region here. So it's at a randomized location. It's unique in every process. And if you try to make a system call from any other place in memory, then your process will just get killed. So it's a nice little thing. And it was inspired by a mechanism from OpenBSD, I should say, although theirs works a little bit differently. Okay, so let's look at some other stuff. So if we go to System Monitor here, we can actually see this beautiful new file manager icon, I was going to say. Look at that file manager icon. That's by Thank You Very Cool. It's also new this month. Let's look at it full resolution here, or 32 by 32. Thank You Very Cool, which is his name, has done a whole bunch of desktop polish patches this month. This icon is just one of them. Also going through menus and stuff and tidying up various text labels. A lot of really good stuff. So what I wanted to show you here is if we go and look at stack, then these symbolicated stacks here that we see, they're actually generated not in the System Monitor program anymore, but in a separate program called the symbol server. So what that does is it's a sandbox ELF parser, basically. So to sort of continue on our process separation theme that we have in the system, symbol server takes addresses and library names and then gives you the function at that address, and it allows us to have completely untrusted ELFs that will get symbolicated by a sandbox process, and we can also cache information so that subsequent lookups are fast. And to test symbol server, I built a simple utility that's called BT for backtrace. So you can use it like this. So we'll get a backtrace for terminal, and it comes out like this. And that's pretty neat. We can't see the kernel stacks because we don't have access to those, but because we're a regular user, but we still get these. And notice that the file names here are actually clickable. So we can open them, and it takes us to the file with that code in it. So classic SerenityOS integration stuff. So that's BT for backtrace. And I wanted to show you with PMAP actually that we also now have a rel-row enabled in all of user space, so both executables and shared libraries. And what that is that it's memory that was previously part of the data segment. It's very similar to unmap or read-only after init actually in the kernel. So it's memory that is writable while a program is being dynamically linked at startup, and then once the dynamic linker, before he calls main, it will go and mark this memory as read-only. So it's for relocations that we process at startup, and then there's no need to ever write to them again, so we go and make it read-only. And I think it's the global offset table that resides in there, so this is a very classic target for exploitation as well, so marking that read-only has strong security benefits. Okay, so that's a lot of talk about various security mechanisms. The last thing I will mention about security is that this month we had the very first full chain exploit for Serenity. So this guy named Vax that's his nickname. He made a full chain exploit where you would open a web page in Serenity in our browser, and it would make its way in through a libjs flaw, and then from there exploit a kernel flaw and get root. It was very cool. I'm going to put a link to his write-up in the video description so you can check that out. Yeah. Okay, so let's look at something super visual instead. So something that is new is the Run Dialog right here. So this was built by Nick, and we need to tweak it for this font size I see, but basically it's a classic Run Dialog. You can type in a program that you want to run, and it runs it. So works as you would expect, and it's supposed to maintain history, but seems like that's not working today, so we have to look at that. Still, though, it's a very cool little app. And let me show you something else that Nick did in the widget gallery here. Wizards. So classic installation wizard style interaction widgets are now available in the GUI library. So these will be super nice for building installers, setup programs, stuff like that. And I think it looks really beautiful. So thank you very much, Nick, for building these. And maybe you've already noticed this, but we also now have window shadows. So we have these nice, tasteful shadows around windows. They also show up under menus, which I think looks really nice, and even under tooltips. So that was Tom who added those. Thank you very much, Tom. I've been longing for the day when we would have shadows, and now we're there, so that's cool. And let me show you another goofy thing Tom did. So he added the ability to remove the window frame from the spinning cube demo. And this thing actually, it will do hit testing based on alpha values. So if I put the mouse cursor here, you can see that when the cube spins so that it covers the mouse cursor, then it changes from being over the terminal to being over the cube. I think that's very neat. And the original point of this was just to support, eventually support complex window shapes. But just that cube demo, I think, is really neat in itself. So let's look at something else. So we've had TrueType font support brewing for a while, and it's still not like completely production ready. It has some glitches, but Stefan has been doing a great job on improving libttf, and here it is, used in the terminal, looking pretty good. We still have some issues that glyphs are a little bit misaligned sometimes. And of course we have a lot of TrueType, OpenType features that need to be implemented, but it is looking pretty promising. By the way, since we're in terminal, so here I've added this concept of a tool window, which is a type of window that is associated with a main window and has a slightly smaller window title bar, and it's not minimizable or maximizable, has no window icon, and it sort of allows you to interact with the properties of a main window's content. And it's some kind of cross between tool windows from Windows and inspector panes from macOS. And I think it looks pretty good. Okay, let's look at Hack Studio. So in Hack Studio, we now have this thing called New Project. So this is another cool thing by Nick. We have project templates, so we can decide to start on a graphical application here, for example. I'll call it GUI. And it actually builds an application for us that we can start working on right away. Oops, double oops. Let's try that again. It's a little bit crashy. I guess we'll call it Mooey this time. So I wanted to build it. Oh, that looks really, really nasty down there. I think maybe that's because of the font. Let's see. Anyway, we can build and run the app from Hack Studio. Pretty cool. So thank you very much to Nick for adding these sweet project templates. And let me see if I can get a good font. Yeah, that looks better. So since we're in Hack Studio, let me show you something else cool. So Itamar has been working hard on CSS Parser, a CSS Parser for Hack Studio, and it's now actually able to search for function declarations. So I can search for like oh wait, well, it needs to be something included, like unget C from stdio, and it takes me to the function definition or declaration. And I can tap on things that make the C++ language server crash. So that's not a great feature, but it's very much in development. But I think it's still super cool that we are actually building a C++ parser for Hack Studio. So clicking on my struct takes you to the declaration of my struct. And you can also search here in the locator, which I bring up with Control K. It's the thing down here, and I can type in here like my struct, and it finds my struct in main CPP, container, and so on. And it seems to crash when I press undo, so need to look into why undo is so broken. But either way, thank you very much to Nick for the awesome project templates, and Itamar for the budding C++ parser support. And just a reminder to myself to go and work on Hack Studio stability. Okay, so some other stuff. If we just open a text editor, and I'll just bring up this view right here. We now have different wrapping modes. So previously we only had no wrap or wrap anywhere. So this is wrap anywhere. But Zach has implemented wrap at words or word wrap. So now it doesn't break in the middle of a word, but rather it forces words to be like either on one or the other side. So that's pretty cool. Thank you, Zach, for doing that. Okay. Browser, another thing that has been receiving some love. So in the last month, we moved to, in the previous month, I should say, we moved to multi-process browser for security and stability purposes. So, and a lot of features broke when we moved because they didn't have multi-process implementations. So Brandon has now gone and implemented view source, which was previously broken. So this is now multi-process enabled. We can actually view the source of a web page that was open in multi-process mode. And also Brandon has implemented the JavaScript console in multi-process mode. So we can now do stuff like this. Document body first child. I don't know what that even would do. I guess remove some text node. Does that even work right? Let's try alert instead. Hello. Yeah, so you can see that it actually does run JavaScript. So thank you very much, Brandon, for working on this stuff. That's awesome. And there has been a lot of work on web compatibility and JavaScript correctness. So Linus has done a lot of cool work on the code generator that we use, so that, for example, you can now create new web objects from JavaScript with a new keyword, like new range or new element and stuff like that, right? And Sviatoslav has implemented CSS Import Rules, which is not the most popular feature, but it's used by a lot of CSS test suites, which will be very beneficial for us. So thank you, Sviatoslav, for that. And oh, since I talked about security earlier, I guess I could also mention that the JavaScript heap is now randomized. So if we look at the web content process memory layout, we can see that JS heap blocks they're just at these random addresses in memory. Previously, they were all just laid out sequentially. So just a little bit of ASLR for the JavaScript engine. Okay, so something else. We've done some work on the profiler. So if we bring up the profiler here, and actually let's profile a browser. That's not how you do that. It's this how you do that. Do a little bit of resizing. And what was it called? 151. So the profiler now has some new tricks. So we have these text labels up here that just shows you where in the timeline you are. And when you're selecting, it displays the selection. So that was Sahan who did that. Thank you very much for that. And I've gone and moved the object of each symbol to its own column. And a new feature here is the samples tab, where you can look at each individual sample in the selected time range. So each one of these things on the left-hand side here is a sample, and on the right-hand side you can see the complete backtrace for that sample. This is very good if you want to get an idea of exactly what was sampled and when. And of course, it responds to range selections up here in the timeline. Okay, so some other stuff is there's been a bunch of compatibility work. So we keep moving forward on VirtualBox and VMware support. I haven't actually tried that myself, so I don't know what it looks like, but Luke has been doing a lot of good work on it. And we also this month got an NE2000 Ethernet card driver by Jean-Baptiste. It's a pretty old card, but he had one that he wanted to use for Serenity on his real machine, so that helped him get going, so why not? It's pretty cool. And then ports, we have a bunch of new ports this month. The biggest port in February is CMake by far, which was done by Ali, which was a lot of work. He had to do a whole bunch of things to get CMake running, but he did, so thank you very much, Ali. It is now possible to build Serenity on Serenity, although it takes a very long time. So there's a lot of performance work that we need to do with that. Still, it is cool because now we have CMake. And then John did a bunch of ports, like little ones, like libtiff, bison, libjpeg, and Marcel did TinyScheme, I think. So there's now a scheme implementation as well. Yeah. Oh, and then finally, I wanted to call out a really awesome thing that Ali did, which was that our format string functions now have compile time checking. So we were using a whole bunch of latest and greatest C++ features to implement compile time type checking and format string verification for our debug line and related functions, which is really kick-ass. And thank you very much, Ali, for working on that. That's been so great. And I've actually gone and tried to remove all uses of printf style formatting. There's still a whole bunch left, but I got rid of both the debug printf and kprintf. So it's really nice to get rid of these less trustworthy format string functions. Anyway, I think that was everything I wanted to show you today. So, it's been another awesome month with lots of stuff happening. Sometimes it's hard to keep track of everything, but it's really nice to go through it at the end of the month like this. So, thank you very much for checking out this video and staying up to date with the project. We're just gonna keep on going into the future. And if you ever want to talk, you can find us on the Freenode IRC network in the SerenityOS channel. So drop by and say hello. Other than that, I will see you all next time. Bye.